So let's talk about reference triangles. So reference triangles, there's actually three different angles we have to know and two different triangles that'll present us with those angles. Okay, so pretty much what you're expected to know is you're expected to know exact number values for sine, cosine, and tangent of the following degree measures: 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay, so you're expected to know the exact values for these. If you guys are up to radians, I'm going to make a separate video for radians. So if you're looking for radians, find another video. I'm dealing just with degrees today. Okay, so essentially you need to know the sine of 0, the sine of 30, the sine of 45, the sine of 60, the sine of 90. I made you guys some notes. They're up on the website, but they only have sine and cosine on them. The first thing I want to note is that there are two columns. One is in degrees, so this is sine 30, sine 45, sine 60. This is in radians. Okay, this is in degrees. This is in radians for cosine. So these are the decimal numbers, the approximations, and these are actually what we're worried about down here, which are the exact values. So these are your three reference triangles. There's a 30, 60, 90, and a 45, 45, 90. But notice the last one is a 60, 30, 90. So it's actually the same triangle. We're just going to turn it the other way. So really, it's only two triangles. Okay. So if you know these two triangles well, then all of these things will fall into place. Okay. So let's start like we did in class today. So quick. This is an isosceles right triangle. We know it's isosceles because it's 45 degrees and 45 degrees. Okay. So we know since these two angles are equal, this is an isosceles triangle, and we know these two sides are equal. To make this useful, we need to know one more piece of information. We need to say that the hypotenuse is 1. And as we get to do the unit circle, it will be more apparent why we make that 1. So how do we figure out these two sides? Well, we know that a squared plus b squared equals c squared, right? Pythagorean theorem. But we also know that these are both the same, right? So like we said in class today, this is really x squared plus another x squared is equal to 1 squared, right? A squared, b squared, c squared. X squared and x squared is 2x squared, and 1 squared is 1. Let's divide by 2. We find that x squared is equal to 1/2, and our last thing is you take the square root of both sides. So x is equal to the square root of 1/2. It's not 1/4. The square root of 1/2 is not 1/4. Okay. So we need to put this in a different form now. Okay. So this is the number, right? Whatever. If you break out your calculator and you said, hey, what's the square root of 1/2? It will give you this number. Okay. So this is the number. But here's the thing. We don't want the decimal approximation. We want the exact number. In fact, if you go on IXL, what it's going to ask you for, I don't have it open right now. If you go on IXL, what you'll see is they're going to ask you for the exact value. So we need to change the square root of 1/2 into something a little more appropriate. So first of all, this is really the square root of 1 over the square root of 2. Remember that the square root goes to the top and to the bottom. Square root of 1 is 1, right? But what we need to do is we're not allowed to leave radicals in the denominator. We always want to simplify our denominators. So what I can do is I can multiply this by the square root of 2, right? Square root of 2 times square root of 2 is equal to 2, right? But again, if I multiply the bottom by square root of 2, I multiply the top by square root of 2. 1 times square root of 2, square root of 2. So this is the number. X is equal to radical 2 over 2. These are the same number. This is just the more appropriate version, okay? So x is equal to radical 2 over 2, and that's on both of these, okay? So again, what is that number approximately? It's about 0.7071. So if you see this number, like if you're doing some computations on your calculator and you see this number, it is the square root of 2 over 2. And just to show you that it's the same number, square root of 2 divided by 2, again, same number, okay? So we know something now, right? We know the following. Get rid of it all. Okay. We know some things. We know that Tallahassee is the capital of Florida. So if I said head, what is the sine of 45? Remember, your ratio for sine is opposite over hypotenuse. So you can pick either angle. I'm going to pick this one. So it's the opposite over the hypotenuse. So it's the square root of 2 over 2 divided by 1. And anything divided by 1 is just itself. So that's why we made the hypotenuse 1. So what is this sine of 45? Square root of 2 over 2. What's the cosine of 45? Again, now it's adjacent, same number over hypotenuse. So this is going to be an important value for us. This is the place where sine and cosine are the same. And your last thing, hey, what's the tangent of 45? Okay? And the tangent of 45 is going to be what? Opposite over adjacent. So it's going to be the square root of 2 over 2 over the square root of 2 over 2, which, believe it or not, is 1. So you know some numbers. The square root of 2 over 2 divided by anything divided by itself is just 1. So what are we going to get? Tangent of 45 is going to be 1. Okay, so we know some numbers all of a sudden. And before, if you put sine of 45 in your calculator, if you just said, well, hey, what's the sine of 45? You would just get this number, right? Now we know where that number came from, okay? So this is one triangle right here, okay? All right, your other one, the 30, 60, 90, okay? 30, 60, 90, okay? Now again, we're going to make our hypotenuse 1, okay? In order to do this one, to get some of the numbers, because now we don't have that thing where they're both the same, right? You know, with the 45, 45, knowing that these two are the same amount, right, that helped us because then we only had one variable. Here, unfortunately, we have two variables. So we need to find another way, and there is another way. So let's go ahead and let's pretend for a second that we reflected this over like an x-axis kind of thing. So that makes this 60 degrees down here and this 30 degrees down here. Well, now, if you see it, there's an equilateral triangle there, right? 60, 60, and 30, 30 makes another 60. Well, it tells us that this is 1 and that this whole side over here is 1. Well, again, let's think about what we know about equilateral triangles and isosceles triangles, really. Oh, this 60-degree angle is bisected right here, which means it makes a right angle with this base over here, which means that this is 1/2 and this is 1/2. These are bisected, okay? So once we know that, okay, we can kind of get rid of all the rest of this nonsense because now we know something else. I know your temptation is to turn that into a decimal. Don't turn that into a decimal. Not yet, okay? Now, we only have one variable. So what can we say? X squared plus 1/2 squared is equal to 1 squared. Well, x squared is x squared. Nothing with that, right? 1/2 squared is a half times a half, which is a Carter. And 1 squared is 1. We're going to subtract 1/4. And again, I know your temptation is to put it in a decimal. Don't do it. Don't do it. Okay? 1 minus 1/4 is going to equal 3/4. Okay? Square to this side, take the square to this side. X is equal to the square root of 3 over square root of 4, which is radical 3 over 2. Okay, and again, if you do the Pythagorean theorem, you can check this to see if it's true. But what do we know now? We know now that this is the square root of 3 over 2. So now we know a bunch of things, right? So what do we know? Well, we know sine, everywhere sines. All right, so sine of 45, we knew that one. That was the square root of 2 over 2. Sine of 30. Sine of 30 is what? Opposite over hypotenuse. So it's 1/2 divided by 1. It's 1/2. Okay, 30, 45, 60 was one of the other angles we wanted, right? Sine of 60 is going to be opposite. Okay, so now opposite from this angle, square root of 3 over 2 over 1, which is square root of 3 over 2. The other two angles we got to know are the following. Well, I know that the upper and lower boundaries, the lowest sign can be a 0 and the highest sign can be as 1. Well, if these numbers are going up, and they are, right? Because we said this is 0.5. This was about 0.7071. This was about 0.8660. Again, follow the pattern. They're going up, 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 and if you go down the other way, down. Okay. So there are your 5 critical values for sine. Okay. So what are they? Sine of 0 is 0. Sine of 30 is 1/2. Sine of 45 is the square root of 2 over 2. Sine of 60 is the square root of 3 over 2. And the sine of 90 is 1. Let's do cosine. Well, again, what do we know here? Cosine of 45 we found in the last one was square root of 2 over 2. So let's do the cosine of 30. Well, that would be the adjacent over the hypotenuse. Square root of 3 over 2. The cosine of 60 is going to be adjacent 1/2 over hypotenuse. So if you notice, these numbers have flipped, yes? And that goes back to something we said a long time ago, right? Is that these kind of complementary angles, this 30 and this 60, will have the same number. Will have the same number. 45 and 45 has the same number. 60 and 30 has the same number. And again, if we kind of follow that pattern, cosine of 0 is going to be 1 as these numbers go in the other direction. And cosine of 90 is going to equal 0. Okay? The last one we need to know, which is not in your sheet, is tangent. Okay, so we need tangent of 0, tangent of 30, tangent 45, we said was 1, tangent of 60, and tangent of 90. Okay. I didn't put tangent on your notes because your notes are for the unit circle, and tangent's a totally different animal, but let's do it anyway. So again, what's the tangent of 30 is going to be what? Opposite over adjacent. Oh boy, so what's 1/2 divided by 1/2 divided by square root of 3 over 2. Again, if you're dividing, we can kind of cancel these out. We'll find out this is 1 over the square root of 3, but like we said, we can't leave radicals on the bottom. Multiply the bottom by square root of 3 and the top by square root of 3. You're going to get radical 3 over 3. So tangent of 30 is going to be radical 3 over 3. Okay? Tangent of 60 is going to be the opposite of that, right? What's it going to be? Tangent of 60 is going to be what? Square root of 3 over 2. Did I do this wrong? Opposite over 2. Okay. And the tangent is going to be opposite over adjacent. So we're going to have the square root of 3 over 2 over 1/2. Right? Again, opposite over adjacent, which would just be the square root of 3. Okay. Again, the 2's cancel. And you're just left with, oops, these cancel, and you're just left with the square root of 3. Okay? Okay, now, things you can't see quite so clearly from this that I just kind of have to tell you is that the tangent of 0 is 0. Okay? These numbers, again, are going up, so we can say this is here. But if you notice where sine and cosine had a limit of 1, the square root of 3 is a number bigger than 1. Okay? So what you're going to see, and eventually you'll see it, is that as you increase, the tangent of 90 does not exist. It's undefined. And we'll talk about that in extreme detail, okay? So what I suggest you do is as you're doing your IXL, kind of keep this chart handy. You might want to write them down or just kind of keep this window open. But these are the only values you need to know, okay? So again, we're going to look a lot more closely at the relationship between sine and cosine. What's going to be more important for tangent is where does it exist and where does not exist, okay? So we'll take a look at that in the coming weeks. Thanks, guys.